On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at logarithmic differentiation, and this is going to be an introduction. We want to find y prime, and we already have the function y equals this stuff. And all I've done here is I've rewritten it, this radical here, x to the 1/3 power. I've worked this problem out using the product rule because I want to show you sometimes you don't necessarily have to do the product rule. Maybe logarithmic differentiation will be quicker or better. This one's not that bad using the product rule, but I'm going to come and show you at the end that we get the same answer using what's called logarithmic differentiation. So pause the video real quick, look over all this, but I'm going to walk through this with you real quick before we actually do the logarithmic differentiation. So I'm calling, this can be my f and this can be my g. So I'm taking f prime, these first two pieces you see right here. That's the derivative of e to the x squared is e to the x squared times 2x. Don't forget your chain rule for that part. Times g, I'm leaving that part alone. Plus, now we take the derivative of this, pull the 1/3 down, x to the negative 2/3, because remember you subtract 1 from 1/3, and then we just multiply that by that first function that we called f. And then everything from here on down is a matter of simplifying it down, making it look a little bit better. And what I've done here is I've shot that 1/3 x to the negative 2/3, I shot that down to the bottom. I wrote a fraction out of this piece here to get that. Then I multiplied all of this by 3x to the 2/3, as you can see right there. I multiplied all that in green to get a common denominator. And then next what we did here is we added exponents. X to the 4/3 times x to the 2/3 is going to be x squared because you get 6/3 as your exponent. And then factoring out a GCF, we factor that e to the x squared out, leaving us with this answer down here. Now again, pause the video, work that out using product rule, check out some of the previous videos on product rule. Let's look at logarithmic differentiation now. So we have y equals e to the x squared times x to the 1/3. That's the cube root of x. What I'm going to do with this, logarithmic differentiation, it's not absolutely required. As you can see, we just did work this out using the product rule, but I'm going to take the natural log of both sides. So natural log of y is equal to the natural log of this stuff right here. And what we want to do with this is we want to break this up using properties of logarithms. And since we are multiplying these two pieces together, we can break this natural log up into two pieces using addition. So it looks a little something like this. Natural log of y is equal to natural log of e to the x squared plus natural log of x to the 1/3. Now applying our power rule, we can pull these powers, that's a property of logarithms, we can pull these powers down in front of these two logs. Therefore we have natural log of y is equal to x squared natural log of e plus 1/3 natural log of x. And since the natural log of e is equal to 1, we don't really need that. And we can take the derivative now using what we call implicit differentiation. So the natural log of y, if we differentiate both sides now, the natural log of y is going to be 1 over y, just like the natural log of x, its derivative is 1 over x. Well, since we're differentiating with respect to x, implicit differentiation tells us to tack on that y prime. This is going to be equal to the derivative of x squared is 2x. The derivative of 1/3 natural log of x is 1/3 times 1 over x, because the derivative of natural log of x is 1 over x. So I'm just going to write that as 1 over 3x. And then from here, what we want to do is multiply by y to get y prime by itself. Therefore, we have y prime is equal to y times this stuff, 2x plus 1 over 3x. Now, this does not look like our final answer because notice we have a y over here. Well, recall back at the beginning, y was equal to this stuff right here. So let's substitute this into this y spot that we have here. Therefore, y prime is equal to e to the x squared times x to the 1/3. This is the y piece that we have brought down. We substituted in, and then we multiply this by 2x plus 1 over 3x. Now let's clean this up and let's see if we can make it match this with the product rule that we did a moment ago. So y prime is equal to, I'm going to distribute all of this stuff to these two pieces over here. So e to the x squared, x to the 1/3 times 2x is going to be 2x. Now this x is raised to the first power, so think of that as being 3/3. And if we add these two together, we get x to the 4/3, and we have e to the x squared. And again, what I did here is I distributed this piece times the 2x. Now I'm going to take this stuff here times the 1/3x. That's going to give us plus e to the x squared. And since we have x to the first power at the bottom and we're multiplying this over here, we can actually subtract our exponents now. So this is a 3/3, kind of like that one. And if we take away a 1/3, we're going to have 3x to the 2/3 power at the bottom when we distribute all of this over here. So again, subtract your exponents. We take that 3/3, that exponent of 1, minus 1/3. That's how I got that 2/3 at the bottom. And if you look and see what we have here, though this does not match our answer that I have boxed, it does match what we have right here. Notice that matches perfectly. So if we were to go through and do all this common denominator stuff and simplifying, factoring out a GCF, we would end up with the same answer. Now, one may think that this is harder than the product rule, but sometimes logarithmic differentiation is the only way that you can actually differentiate a function. For example, suppose I had y equals x to the x power. How do we differentiate that? Well, that's what we're going to be doing in the next video, where we do a couple of examples where logarithmic differentiation is pretty much the only way I think that you could find a derivative. And it really revolves around when you have a variable term raised to a variable power. That's something we have not seen yet in differentiation for Calculus 1. But for now, I did want to give you an introduction showing you that we can get the same answer using the product rule in this case, and then applying logarithmic differentiation, where ultimately this piece again does match what we have right here. So we can see that that would simplify down to this. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.